everyone. We're going to find the directed distance s in feet during the time interval 0 to 2 of object P moving along a coordinate line subject to V equals t minus 1 times e to the power of negative t. The setup is your formula is going to be your directed distance is s, and that equals the integral from 0 to 2 of absolute value of v of t dt. So let's use some substitution. This is going to be the integral 0 to 2 of absolute value of t minus 1 times e to the power of negative t dt. I can pull this out because this is just e1 divided by e to the power of t, and my t is positive here. So basically, pulling that out, I'll get the integral from 0 to 2, absolute value of t minus 1 times e to the power of negative t dt. All right. Looking at this, since we have absolute value of this linear term, what we're going to do is look and see where t minus 1 equals 0, and that would be t equals 1. So what we're going to look at is where t minus 1 is greater than or equal to 0, and where t minus 1 is less than 0. And let's just don't put the, because this is absolute value, so we're having to look at what it means, what's going to happen. So basically we're going from 0 to 2, and I have this 1. So if I substitute in a 1/2 into these, it's going to be negative. 1/2 minus 1 is negative. So this is going to be negative. If I substitute in, say, 1 and 1/2, this is going to be this one. So this one's going to be positive. Therefore, when it is positive, I'm going to have t minus 1. But when it's negative, I'm going to have negative t minus 1, which equals 1 minus t. So when I set up my integral, what I'm going to set it up as is the integral from 0 to 1 of 1 minus t. I'm splitting it up because from 0 to 1, it's negative. So I'm using this one. So that's going to be that times e to the power of negative t dt. And then add it to the second interval from 1 to 2. And that one is positive, so you're going to use t minus 1 times e to the power of negative t dt. And then we can integrate. So for this one, let's look at that one. Normally you would use integration by parts, but what we can do for the integral of 1 minus t times e to the power of negative t dt, I can use the tabular method or tabular integration, also known as the shortcut. And I'm going to take the derivative of my linear term and integrate my exponential term. So you write down your algebraic expression, and you take the derivative until you get to 0. So when you take the derivative, you're going to get negative 1. And when you take the derivative again, you get 0. Now for this one, you copy down e to the power of negative t, and you keep integrating it until you get to 0. So this is going to be negative e to the power of negative t. And then this one's going to be e to the power of negative t. And then you do this diagonals here and multiply. So this one you're going to have plus, this one is minus. So what we're going to get is 1 minus t times negative e to the power of negative t. And then you're going to minus negative 1. So it's going to be plus 2 negatives here, e to the power of negative t. So this gives you negative e to the power of negative t plus t e to the power of negative t. And then we still have this plus e to the power of negative t. All right, so what happens is these two cancel, and this is what we get. So our answer would be t times e to the power of negative t, and then plus c. So let's go back to what we have from the integral from 0 to 1 of 1 minus t times e to the power of negative t dt. That's going to equal t times e to the power of negative t, and we're evaluating this from 0 to 1. When you substitute in 0, it's going to just zero this out. So just substitute in the 1, and that's going to give you e to the power of negative 1. So that's for that part. And for the second one, we had the integral from 1 to 2 of 1, let's see, is this the same one? 1 minus t, let's see, the 2, 1, yeah, it should be t minus 1, whatever. Let me write that one down. So this one's going to be t minus 1 e to the power of negative t dt, and that's going to give you the same thing, t e to the power of negative t, but we're evaluating it from 1 to 2. And when you do that, you're going to get 2e to the power of negative 2 minus e to the power of negative 1. So putting it all together, we're going to take this one minus that one. So let's do that. We're going to have your directed distance equals e to the power of negative 1 minus 2e to the power of negative 2 minus e to the power of negative 1. All right, this is going to equal, let's see, we have, there's two of these because this is going to be a minus and negative is going to make it a positive. So we have 2e to the power of negative 1, and then minus this one, minus 2e to the power of negative 2. I can factor out a 2, and that would give me e to the power of negative 1 minus e to the power of negative 2. And it actually looks better if you take away those negatives and just write it as 1 divided by e minus 1 divided by e squared. And that is your final answer. Thank you. Have a nice day. Bye-bye.